Cyclic acetal formation and protection of carbonyl group. Aldehydes or ketones react with ethylene glycol. Aldehydes or ketones react with ethylene glycol in the presence of dry HCl to form cyclic acetals. So this reaction is used to protect the carbonyl group. Aldehydes are more reactive than ketones towards glycol. Now let us see how they protect the carbonyl group. Now I will take one example and explain. This is the compound. This compound should react with Grignard's reagent and form a tertiary alcohol. This compound should react with Grignard's reagent and form a tertiary alcohol. But if I treat the compound directly with Grignard's reagent, aldehydes are more reactive than ketones. So if you see the compound given, there is aldehyde group as well as ketonic group. So if I treat with this what I want to prepare from this compound, I want to prepare a compound in which there is aldehyde as well as tertiary alcohol. Means what I want to convert this compound to? I want to convert this compound to this compound. Okay. Compound 1 should be converted to compound 2. Means aldehyde group should not get affected and ketone should be converted to tertiary alcohol. How can I convert ketone to tertiary alcohol? By reacting with Grignard's reagent followed by hydrolysis. But if I directly treat the compound 1 with Grignard reagent, aldehyde being more reactive reacts with Grignard's reagent and you will get a secondary alcohol. But I don't want that reaction to happen. I don't want aldehyde to react with Grignard reagent. Ketone should react with Grignard's reagent. So what I should do? I should protect the aldehyde group. So what will I do now? I will treat this compound with ethylene glycol. I will treat this compound with ethylene glycol in the presence of dry HCl. So what happens? Aldehyde being more reactive forms a cyclic acetal. So what will I get? Double bond O. Aldehyde being more reactive will form a cyclic acetal like this. So now this compound is treated with Grignard's reagent. This compound is treated with Grignard's reagent. What Grignard's reagent followed by hydrolysis, what happens? First, when it is treated with Grignard's reagent, what happens? O MgBr what will I get? OMgBr CH3 here and cyclic acetal. This followed by hydrolysis. This compound followed by hydrolysis. What will I get? A tertiary alcohol and the aldehyde will be regenerated back. On hydrolysis, what happens? This bond will cleave and you will get a alcohol which loses a molecule of water to form aldehyde. So here what we are using? We are using ethylene glycol, that is acetal formation, to protect the aldehyde group from reacting with Grignard's reagent. Okay. So again I am explaining. Let us learn this equation even in more detail. So what happens here? Double bond CHO is there. First, this compound is treated with glycol in the presence of dry HCl. So, aldehyde being more reactive reacts with glycol to form a cyclic acetal. It forms a cyclic acetal. Okay, this compound is now treated with Grignard's reagent. This compound is now treated with Grignard's reagent. So what will I get? CH3O MgBr, and here COOH. Okay, this Grignard's reagent followed by hydrolysis. Hydrolysis means what happens? The acetal also will get hydrolyzed. If acetal get hydrolyzed, you will get compound like this. 2OH, OH, HOH means again glycol will be regenerated. And this carbon atom is having two molecules of OH on the same carbon atom. So it loses a molecule of water to form aldehyde. So what will I get finally? From this what will I get? OH, CH3, CHO. This is the final product. Now this is acetal formation. This is ketal formation which is used to protect the carbonyl group.